Hey folks, Professor Gray here. Ready to talk about descriptive statistics and descriptive depictions of data. First off, what are descriptive statistics anyway? Well, as the name implies, that's information that describes sample data. It describes. And they characterize the center or the spread, also called variation, of a set of data. And there are two main branches of statistics, at least in this course. Descriptive statistics that describe data, and inferential statistics, which we talk about later on, in which you take your sample data and you make generalizations about an entire population based upon it. First, here's some new notation. Capital sigma looks a lot like an E, or a stylized E. It's a Greek letter, and it denotes the sum of a set of values, summation. We use X to represent individual data values in a way that you're familiar with. Lowercase n represents the number of data values in a sample, so that's sample size. Capital N represents the number of data values in a population, that's the population size. It's much easier to know the sample size than the population size. Well, as mentioned before, descriptive statistics usually describe either center or spread. So we'll talk about a few measures of center. A measure of center is the value at the center or middle of a data set. And we'll talk about three different types: mean, median, and mode. Rounding rule for these, unless otherwise posted, is to round one decimal place past the given data. So if your data is all in whole numbers or in integers, then you would want to round one decimal place. If it's all in two decimal places, you want to round 3. The mode, on the other hand, is not rounded at all. It comes directly from the data and does not need to be rounded. First measure of center is the arithmetic mean. That's the measure of center obtained by adding the data values and dividing the total by the number of data values. For sample mean, the symbol used for that is X bar. That's found by adding all of your data numbers up, or data values up, in the set and dividing by the size of the sample. And the population mean, we denote that with the Greek letter mu. Looks kind of like an M and kind of like a U, mu, mu. And that's found by adding all the numbers up in the population and dividing by the size of the population. Well, you've probably done this before. You add things up and divide by the number of things you have. That's also known as taking an average. Now, in statistics, we refer to it as the mean. Let's do some examples. Example number 1 is for the sample 12, 25, 38, 5, and 20. So if I get my calculator out, I can add those numbers up. All right, now I'm ready. I can add those numbers together. And I'll divide that by the total number of numbers I have. 1, 2, 3, 4, 5 numbers. So I get 20. So in number 1, using notation, X bar is equal to 20. For the population, I do the same thing. I'll add 15.5 plus 12.7 plus 19.2. Divide that amount by 3, because there are 3 numbers. So 15.8 is the mean. Now, since that's the population mean, I'm going to use the correct symbol. Mu equals That number again was 15.8. And that's my mean. Well, there's another way that I can find those numbers using the list tool in my calculator. Here's how to do that. I press the Stat button right here in the middle of the calculator up towards the top and press Enter, and that takes you to your list. So, for example, in number 2, I would type in my numbers in list number 1. Once they're all in, I press the Stat button again, go over to Calc. One var stats is at the very top. That's one variable statistics. And it's a good practice to put in list 1 to tell the calculator what list you're finding the statistics for. If you have a TI-84 or an 83 Plus or some other models, when you reach this point, there may be some things to fill in, such as list and frequency list. The list will be list 1. The frequency list is left blank. If your calculator is like mine and you have a TI-83 and you have to type L1 in on your own, then you do that by pressing the second button and the number 1. Then you press Enter, and at the very top there's X bar. Now, we weren't finding X bar, we were finding mu, but the calculations are the same. You add all the numbers up and you divide by the number of numbers you have. So even though the calculator doesn't get the symbol correct, the number is correct. That's how you can find the mean of a set of numbers in the calculator. Well, we can also find the mean from a frequency distribution or histogram. Here's the formula for that. F sub I is the frequency of the ith class, so frequencies. X sub I is the midpoint of each class, so frequency times midpoint. Add up all of those products and divide by the total of the frequencies. Let's do an example. Number 3 here, we need to find the mean of the wild bear data shown, either from a frequency distribution or from a histogram. The process is the same for either one. Well, the first thing you've got to do is find the midpoints of each class. The classes shown don't have the midpoints shown, so we'll have to find those on our own. So for number 3, that's my first step. Let's find the midpoints. Well, the midpoint of 26 and 95 would be 26 plus 95, and divide that by 2. So you get 60.5. All right, for the next class, 96 through 165, you would add those two numbers together and divide them in half, and you get 130.5. Oh, now notice there's a pattern here. The difference between these midpoints is also the class width. Yeah, the class width of this graph is 70. 96 minus 26 is 70. 376 minus 306 is also 70. The difference in the midpoints will also be 70. So I can just add 70 to each number to get the next midpoint. 130.5 plus 70 is 200.5. Then I get 270.5. 340.5. And lastly, 410.5. I have 6 classes, and those are 6 midpoints. So I'm done finding the midpoints. Now the frequencies are the same ones from the frequency distribution or from the histogram, since they give us the same data. The process is the same for both. Now, if I were finding these with as little calculator help as possible, I would multiply each midpoint by the frequency. Then when I find those products, I would add them all up and divide them by the total of the frequencies. However, the calculator actually makes short work of this. If, again, I go to Stat and enter in my list, in list number 1, I can put my midpoints. And in list number 2, I put in my frequencies. I just keep them in the same order they appear in. Once those have been entered, I go to Stat, Calc, 1 var stats at the very top, and be sure to tell your calculator that you're using list 1, the midpoints, with the frequencies in list 2. In a TI-83 or something similar, I press second 1, the comma button, which is right above the number 7, second 2 for list 2. And when I press enter, the very top is my answer. If I have a TI-84 or an TI-84 Plus, something along those lines, then your list is list 1. Your frequency list, it appears as freq list, is list 2. And the calculator will give you your mean. So the answer to that problem is X bar equals 197.7. So the mean of the wild bear data, the mean weight of the wild bear in this sample, is 197.7 pounds. The weighted mean is very similar to the mean of a frequency distribution or histogram. The formula is almost exactly the same. Instead of F's, we have W's. The W's stand for weights. So the W sub I is the ith weight. X sub I is the ith entry. You multiply a weight by its entry. Add up all of those. That's what the summation tells you to do. And then divide by the sum of the weights. Here's an example. Mr. Gray teaches math. Final grades are calculated as follows. Tests 1 through 3 are 15% each. Homework is 10%. Participation and attendance is 5%. Projects and quizzes are 5%. The final exam is 25%. And the labs are 10%. Well, if you made the following grades, what is your final overall grade? So for number 4, one way I can calculate this is by taking my grades and my weights and listing them. So my grade for test 1 was a 92. My weight is 15%. I write that as a decimal, 0.15. Test 2 was a 94, also worth 0.15. The grade for test 3 was a 98. That's worth 0.15. The final exam was an 87. According to the problem, that was worth a quarter of the grade, 0.25. Homework was a 98. That's worth 10% or 0.10. Labs, 91. Also 10%. Projects and quizzes, 84. That's worth 5% or 0.05. Be very careful when you change one-digit percentages over to a decimal. And participation and attendance, 89, also worth 5%. Well, according to the problem, or to the formula, I'm going to multiply each grade by its weight. That'll give me the product of each. So if I go over to my calculator, 92 times 0.15 is 13.8. .94 times 0.15 is 14.1. Whoops. 98 times 0.15 is 14.7. .87 times 0.25 is 21.75. .98 times 0.1 is 9.8. 91 times 0.1 is 9.1. 84 times 0.05 is 4.2. And lastly, 89 times 0.05 is 4.45. All those products are the part of the formula highlighted right now. The next thing I need to do is add those products up and divide by the total weights. So that's what I do next. I'll add those together. And I get 91.9. That's the numerator, the top part of the fraction in the formula. The bottom part is the sum of the weights. Well, if I take a look at all the weights and add those up, I get 100%, or 1. So 91.9 divided by 1 gives me 91.9. That's the overall grade, or the weighted mean. That's how I can do that with minimal calculator help. If you're using the calculator will also find a weighted mean for you. If I go to Stat and Enter, I'm going to clear off my old list. And in list 1, I'll put in the grades. Once all those are in, list 2 will be the weights. Now make sure to put the right weights with the right grade. Now, just like I did in the previous problem, I go to Stat, Calc, 1var Stats. Tell the calculator I'm taking the statistics of list 1 weighted by list 2, or the list is list 1, the frequency list is list 2. And if I press enter, my answer's at the very top. 91.9 is X bar. So that's how to find a weighted mean. A few words about the mean. The mean is affected by extreme values. Have you ever made a really bad grade on a test? Now, what did it do to your overall average? It pulled it down. If you've ever made a really good grade on a project or a test, it pulls your grade up. The mean is affected by extreme values. It's pulled around very easily. It gives in to peer pressure. We refer to it as a not a resistant measure of center. Or something resistant would stand its ground, and even given extreme values, wouldn't move from one area to another. It stays pretty much where it's supposed to be. The mean doesn't do that. It is not resistant. Well, the good news is we have other measures of center that are resistant. One of those is the median. The median is the middle value when the data values are arranged in order of magnitude. In other words, listed from least to greatest or greatest to least. It's denoted by MED. Now, the median is not affected by extreme values. It is a resistant measure of center. It does not get pulled around. It's much harder to pull it around than the mean. Here are a few examples. Number 5, we'll find the median. First thing I'm going to want to do if my numbers aren't already listed in order is to do just that. So I will. 0.66. Oh, missed one. 0.42 comes first. Then 0.48. 0.66. 0.73. 1.10, 1.10, and 5.4. All right, well, to find the median of these numbers, I simply do this. Well, it can't be that one or that one. It can't be this one or this one. It can't be this one or this one. Oh, there it is. So the median in number 5 is 0.73. It literally is the number in the middle. Median sounds a lot like medium. That's the size of shirt that's between small and large. Also, when you drive down the road, if you're on a 4-lane, the name of that thing in the middle of the road that separates the lanes, that's the median. Same idea. Let's do number 6. Again, I'm going to list those numbers in order first. 0.42, 0.73, 1.10, 3.48, 5.40, and 7.02. All right, let's find the median. It can't be this one or this one. It can't be this one or this one. Uh-oh. I've got two numbers in the middle. Well, when that happens, to find the median, find what's in the middle of the two numbers. And anytime you need to find what's in the middle of two numbers, you add them together and divide by 2. In other words, you take the mean of the two numbers, or the average. If I do that in this case, I end up with 2.29. That's the median. Well, what was the difference? In number 5, the median was just there, in the middle. In number 6, I had to add the two middle numbers and divide by 2. There were an odd number of numbers in number 5, 7 to be exact. In number 6, there are 6 numbers. So if you have an odd number of numbers, the median is in the middle. If you have an even number of numbers, the median is in the middle of the two things in the middle, so to speak. Number 7 is already in order. The median of the numbers shown there is 8.5. Why? Well, because the median would have to be between 8 and 9. The number between those is 8.5. One more measure of center that we're going to talk about is the mode. Now, the mode is the value that occurs with the greatest frequency. The class that occurs with the greatest frequency is known as the modal class. So the mode is the one that shows up the most often. It's kind of like an overachiever. It's there the most. At the bottom of the slide in bold, mode is the only measure of center that can be used with nominal data. That's data that can only be put in order, or cannot be put in order, is only nominal. You only have names and labels. So mode is the only measure of center you can use if you have nominal data. For example, in number 8, that's nominal data. They're colors. The mode is the color that shows up the most often. And that would be blue. Blue is twice mentioned. The other color is only mentioned once. In number 9, those are numbers. The mode of that data set is 17. 17 appears the most often. And in number 10, the modal class of the histogram shown is the class 1 to 10. It has the highest frequency, and thus it also has the tallest bar. You can have one mode, more than one mode, or no mode at all. If a data set has only one mode, we call it unimodal, just like a unicycle. For example, blue, yellow, yellow, green, red. Yellow is the mode, and there's only one. Bimodal occurs if you have two modes. So blue, green, yellow, red, blue, green. Both blue and green are modes. They both occur twice. Neither one of them occur more than the other, but they both occur more often than any other color. Multimodal, that's more than two modes. In that example, 3, 4, and 5 all appear 3 times. And there can be no mode at all. The numbers 1, 2, 3, 4, 5 have no mode. no number shows up any more often than any other. Now, what do you think the histograms or the bar charts of those would look like? Unimodal is going to have a bar taller than all the others. Bimodal will have two bars that are taller than all the others. Multimodal, well, however many modes there are, there'll be that many bars taller than the others. And if there's no mode, all the bars will have the same height. Perhaps it'll be uniform. In another video, we're going to talk about the measure of variation or the measures of spread. That's measures of center.